Phased antennas is something that has really fascinated me for a long time, specifically the Chrisman phasing method. Now, I first tried this over 5 years ago. If I look back on my channel just a little while ago there, and the latest video that I released was 4.5 years ago. So I initially experimented using a design from the ON4UN low band DXing book. And I don't have this book, but hopefully Santa's going to bring it to me. But I was looking at taking two verticals, putting them 1/8 of a wavelength apart and doing phasing that way. So what do we mean by phasing? So we do it by two identical either ground mounted verticals, quarter wave, or raised verticals. But in between them we have some very specific lengths of coax. So in the 1/8 wave phasing we would have a phasing or a feed line to each antenna that's 157 degrees at a frequency, and we would have a delay line at 39 degrees. And I persevered with this antenna for quite a long time, but in all honesty I got quite scunnered. I've used that word about this antenna a lot. Just really annoyed, because one minute I would have it working and the next minute it wouldn't be working, and I really couldn't figure out what was actually going on. So I ended up going on to other things, and then lo and behold, 5 years later, I'm starting to see them pop up again. So I thought I'm going to have another go at this, and that's exactly what I've done, and I've had a much more successful result this time. In fact, I'm delighted with the results that I've actually got. Now, I went back to the initial 1/8 wave phasing again, but I had a lot of frustration with that. I've had this system set up in my garden here for a week now, and I've been doing lots of testing, but I've actually changed to the more common quarter wave spacing between the antennas, using two 84 degree feed lines and a 71 degree delay line. So if you don't know what a phased array is, so you basically send your RF to your antenna system, and the RF goes to one of the antennas at a slightly different time, and that allows you to then send the signal one way, or the majority of the signal one way, or send the signal the other way. So it works on receive and transmit, so you get a little bit more gain, perhaps 3-4 dB in the direction that you're end firing, as we say. But more importantly, that you get what we say is a front-to-back ratio.
Kennen wir alle, und dann wird schon wieder passen. Ja, wünsche ich also schöne Grüße natürlich auch an Foren, und wünsche da weiterhin viel Erfolg und gute Verrichtung. Okay.
So a bit like a Yagi beam. So if you have your beam set in one direction, you get a lot of rejection from the rear. Well, you get the same thing with the phased verticals, and it can be quite pronounced. And in this week, I've seen it up as high as 25 dB. So that's been really impressive. So there's a few elements to this antenna, so I want to give you all the details and the main hints and tips to be able to build this system if you want to do that yourself. But there is commercial variants out there. If you don't want to take this on, you could just you could actually buy the kits. Billy GM6DX, which he's not far from me, just 30 miles along the road. He's done a system for a number of years that you can buy, and just you still need to cut your coax. Or John NJ4Z, he's got a fantastic looking kit, especially if you're over in the States, but I think he actually ships to Europe as well. So if you don't want to do the work building the control and the relay part of it, I would call it, the control and the switching, you can simply buy that, and then you can just put up your antennas. Right, so as I've touched on, you've got two identical ground mounted verticals, and in the middle of that you've got a switching unit, and within that little switching unit you've got a couple of relays. One of the relays basically enables the delay line, so the two feed lines are connected all the time, and you switch in this delay line, so it's delaying the signal to go to one or either of the antennas. And you have another relay in there, which is what we call broadside. So it basically shorts out the connection, and it sends the signal to both antennas at the same time. So in effect you get like a dipole pattern, so you get effectively it's three directions. It's a dipole, or you get end fire one way or end fire the other way. Now I've not found so much the broadside effect huge here, but I'm in a suburban environment. I've got houses all on one side of me here. I've got a big metal trampoline, I've got an antenna mast, I've got a lot of things going on. So I think that the results that I've actually got have worked quite well considering my environment. The biggest part of this project, because I had most of the parts already, was actually designing these. So these are custom printed circuit boards, and I've had these made by GLPCB, and I've probably put learning the software called cloud-based software called Easy EDA. I've probably put in 30 to 40 hours actually designing these, making iteration after iteration. This was actually the Rev 1 board. I ordered this in haste, and while it would work, it wasn't quite right, so I never used this, but I just had a very small quantity and I had a voucher anyway, so I didn't waste too much money. And then I actually got these were version 2 boards, and this is what I'm actually using at the minute. And I've managed to get these working really well, but I do have a revision 2.1. And so all information about this antenna, I'll put that in a GitHub. I've created a GitHub page for me, and I've created a repository specific for this antenna system. So if you want to build it, that's where you need to go. So you get your PCBs. This is the switching one, so you need to populate this. So you need to buy all your components, solder them in. That's relatively easy. Once you've done that, you then need to fit this to, I fitted it to an aluminium box, but you could fit it to a piece of aluminium angle or a bit of copper plate or something. But you need some way of, I like doing that, basically tying all the ground connections together. You then have this switching PCB, which I fitted into another small Hammond box here. So I've tried to do this the cheapest way possible, and you know, because we all want to save a little bit of money. So what it's really cost me is this PCBs and the components that's actually, you know, to put this all together. But other than that, I've had absolutely everything here. So that's really the hardest part. Well, maybe not quite, but I'll get to that. Going between these, you can actually see here. So I've actually mounted an RJ45 socket right on the board, and I'm using 3 of the twisted pairs. So I've shorted out actually three pairs on here. I've actually shorted on the PCB, so we use 3 twisted pairs just to help with the current. Although you're not sending a lot of current, it doesn't take much to switch these. It's milliamps to enable these relays and switch them on and off. So everything's PCB mounted. You can see that if I mount this on here like so. This is one of my test ones, by the way. It's because I've got this light in front of me here. Yeah, so there you go. And I've actually made a little change because you could see that this RJ45 is protruding. Now on the model, on Easy EDA, it looked fine, but these were, so I've moved them back 2mm for the ones that if you want to build this yourself. And I've actually got 5 of these on order of each, 5 of the switching and 5 of the controls. I'll probably not get these for another week, so hopefully I'll get them before Christmas, fingers crossed. So yeah, so you've assembled your PCBs. In your box outside, I've actually bought a weatherproof extension box. So people, you know, Christmas time, they have electrical, you know, mains, electrical extensions, and you can actually buy boxes to put these in. That's what I've put that box in, and it's been up through this recent storm. What was it, Storm Barm? You know, loads of rain, loads of wind, and it stayed absolutely bone dry in that box. So it's absolutely fine for permanent use if you want to do that. Now we get onto the complex part. Now I was talking about the feed line or the phase line, feed or phase lines and the delay lines. So these need to be cut really accurately. And what do I mean by that? I would recommend you to get your coax lines within 20 kilohertz of each other, right? And what I will say is, please go with the quarter wave spacing, because the 8th wave spacing is really just, it's really awkward and I find it frustrating. So go with the quarter wave spacing if you can. So we need 2 84 degree lines and we need a 71 degree delay line. Now I've got on my GitHub, there is a calculator in there to let you work out the length of coax that you need. Don't trust the velocity factor of the manufacturer. It won't be far away, but it's not close enough. You need to take your, use that calculator. Now these lengths of coax are 90 degrees at a frequency. I would call that the check frequency. So you cut your coax line, you terminate one end with a PL259, you connect that to your analyzer. I'm using a Rig Expert AA55 zoom, which is fabulous for this, but you could use a nano VNA just as easy. Now the Rig Expert does have a quarter wave 90-degree stub function, which you could use that, but I like to use the RX chart, and I could see where resonance is. So resonance is where you get the X equals 0. Now that's critical. Now basically you just keep trimming your coax until you get to that 0 point. That's all you need to do. Once you get to that 0 point, you're done. Fit your PL259. Once you've done that, then swap the coax round and check it with the other end. You will see a slight difference. Because PL259s are not 50 ohm matched, there'll be a little bit of capacitance and inductance with these PL259s. That can't be avoided. But what I found was, using the crimped connectors that I had, there was about 15 kilohertz difference between the two ends. So that was good enough for me. So I did that for the phase lines or feed lines, and I also did that for the delay line. That was, I've done it quite a few times now, that it wasn't really a big deal. So I then got my fiberglass masts. I put them up in the garden. These don't need to be absolutely cock on, but they need to be pretty close. So we use free space. So my antennas are exactly 5.6 meters apart, which is a quarter wave on 20 meters. All right. If they're plus or minus an inch or two, it's not going to matter. So don't worry about that too much. I made sure I used the spirit level to make sure that they were completely level. Radial wise, I've been using 2 meter long radials, and I've got an equivalent here of about 21 quarter wavelengths. So way more than the 16 radials or 16 quarter wavelengths. I've got loads of copper on the ground. Both antennas are absolutely identical, and I think that's important. They need to, it's not just electrically the same, but mechanically the same. The feed points I have on them are just simple empty plastic boxes, but these have allowed me to put a clamp, so then I can attach that to the fiberglass pole, and then I've just got a single piece of wire running up the mast, on both antennas. Now that was actually the most pernickety bit to do that, was actually to tune both of these antennas. So put up both antennas, connect your ground system, but don't connect any coax, alright, because that will affect things. So get both antennas up, because you do get some mutual coupling between them. So put them both up, alright. So leave one without it connected. Now you need to check where your antenna is resonant, and resonance means X equals 0, not low SWR. Low SWR or your SWR dip will be pretty much where X equals 0 is on a ground mounted vertical, but they are not the same. Alright, so you need to get these very, very close. I actually just retuned my antennas today. My target frequency was 14.175, but even then I ended up with both antennas set at 14.2, and they were absolutely within 5 kilohertz of each other. That's how close I got them. But if you can get them within maybe 20 kilohertz, so you need to basically keep trimming one till you get the resonance at the target frequency, whatever that may be. I used 14.175. Disconnect it, put your coax in the other antenna, and check that. And then once you've done that one, go back to the other antenna and make sure they are both exactly the same. If your antenna moves in the wind, you will see difference on that resonance. You will see a wiggly line when you're scanning with your VNA or your antenna I is lowercase. So it's better to do this in calm conditions. Now, also when you're tuning your antennas, you need to make sure you're nulling out the coax that is on your antenna analyzer or VNA. If you have a VNA, you will know about the calibration feature that you need to do. You need to do that same calibration feature with your antenna analyzer. Now, Rig Expert allows you to do that on the Zoom models, so I just take any length of coax. It's long enough just to get to both the antennas, but far enough away so I'm not standing right up next to them. I've used an SMA to SO239. I then used my SMA open, short and loads. You don't actually need an open, you can just leave it open, short and a 50 ohm load. So that creates a new reference plane at the far end of your coax. So when you're checking your antenna for resonance, you're not taking into account that coax. So that is absolutely critical that you do that, all right? Once, if you've got everything set up, your coax lines and your antennas are tuned, this system will work. Now, I designed this PCB in such a way that you can't see it, but the trace length is absolutely tiny. Now these spacing of these holes, which is for the SO239s on the box when it's outside, spacing between these is exactly 1 inch, 25 mil actually, it's less than an inch. And I wanted them I went as close as possible that I could still fit the connectors. So if you've got big sausage fingers, you may struggle to fit your coax in the field. But what that was to stop me adding extra length onto my coax lines. So I've really thought about this when I've made this PCB. All right. Now, when it gets to on-air testing, now by the way, I've tested this antenna to 900 watts. It's a single-sided trace. The new ones that I've made, I've cleared a bit of the area with the shielding, and I've actually put a double-sided trace on them just for safety. But that will handle. I'm quite sure it will handle 1.5 kilowatts. If you're allowed to run that, that is. But I've run this single-sided trace, 900 watts, sideband, no problem at all. So a bit less obviously for CW and a bit less again for digital modes. Now, what's really interesting is when you start to do the switching in the shack, the remote switching, you don't always see the front to back. 20 meters has not been great this week. All the DX has been on 10 meters. But I wouldn't build this antenna for 10 meters, which I'll cover and I'll talk about in a minute. So there's been very little DX in the band, so I've been relying on stations in Russia, Poland, that type of area, Eastern Europe, to test my front to back on. Italy as well, I've been getting some. And when I was testing this in the morning, I wasn't seeing any front to back, or very little front to back, and I knew my antenna was right. I wait till the afternoon. The same stations, I was seeing 10, 15, 25 dB front to back. Now I could stay on that station for a minute, 2 minutes, the front to back would be there, then all of a sudden the front to back, it just disappears.
The station 2020, 21, 2022, 2024. Thank you very much, and there's nothing on the for today.
Let me see if you can hear any difference. This is antenna 1, antenna 1, antenna 1. And this is antenna 2, antenna 2, this is antenna 2. And then back to antenna 1, this is antenna 1. Any difference with my signal, Rudolph, over?
Antenna 1, 20 dB over 9. Antenna 2, 5 9. 20 dB negative for antenna 2. QSL?
Punkt zasilania jest nawyższym pod kątem 45 stopni. Słyszy całkiem.
Und dann wird schon wieder passen. Ja, wünsche ich so schöne Grüße natürlich auch an Freunde.
And I think what's actually happening is, and somebody can actually help me with this, as the angle that's coming into your antenna, it's not hitting one antenna first, it's coming in higher, so it's hitting the other antenna, and if that signal is bouncing about before it hits your antennas and comes in at a different angle, say it comes in broadside, you're simply not going to see the front to back. Perhaps the polarization is changing, I'm not entirely sure, but it's a completely natural phenomenon that your front to back can vary wildly. Now, we had a band enhancement yesterday, Thursday. So this was about 0800 UTC. I heard a station from Northern England, so I thought, but he was strongest west. And it was actually VK2 CPC. Now he was running an OptiBeam or something. Now I listened to him for about 2 hours yesterday morning.
9 and 9 plus, so you're coming through. Peter. 23IRQ. Rummy John's gone, so he's away, and Bill's not been on either. So John's gone, NEY. Frank is plumber or whatever he's got there.
Although he was side on, so he was just touching the edge of where I was westerly because he was long path coming in long path, I was seeing some really nice front to back on him. So that was really good. So that just completely validated the system. You know, you're not going to get any better DX than that. Now, if that system was just pointed directly, short path, long path to VK, that front to back would be even better. So that was really, really good. He was working on it. I didn't call in. I just left him be. He was speaking to a lot of his buddies back home down south. So that was really interesting and a really good test. Sometimes it was changing where he was coming in short path, where it was just really good to see that how we could make that change. So that's been really, really good. So I actually look forward to when the cycle takes a bit of a dip and actually be able to use this on 20 metres. Now I have a 66-foot doublet here as well, and I adore that antenna. Really, really good. Now when I had this antenna, these phased verticals, switched west, and I was listening to VK, I was then doing an A-B comparison with my doublet, and believe it or not, the doublet was almost up there within about one S unit. Maybe it was just ever so slightly down on the phased verticals. But should I expect any less? I'm on the ground here. I've got a load of obstructions here, and that's why if you're in a suburban environment, I would always encourage you to try and get an antenna above the house line, above the roofs, and it's always going to perform that much better. So do I recommend this antenna? Depends on your circumstances. Doing quarter wave spacing for 40 metres is too tight for me here. I can't do that, so I will do that. I'll go somewhere else, and I want to test 40 metres quarter wave phasing. I've already got the coax lines cut, and I'm quite sure they will work absolutely fantastic. I wouldn't recommend using this antenna on any bands higher than 20 metres. There is better options out there, okay? If you're going to 10, 12, 15 or even 17 metres, you can build a Moxon, build a hex beam. I've done it. It would just be much better. Get your antenna up. Doesn't need to be particularly high for those higher bands, and you're going to get a really good performing antenna. If you're using phased verticals on 15 or 10, it's going to be more difficult to cut the coax lines accurately. It's going to be harder to tune the antennas, so it's not my recommendation to do that. 20, 30, 40, 80. And I will try 80. I'm going to try a linear loaded for 80 because that will work. I've done it on 20, so a linear loaded vertical, 80 metres, that's going to be something else. I just need to find somewhere with 20 metres to actually put that out. Okay guys, so hopefully I've covered all the pertinent points. Again, down in the description there'll be a link to my GitHub. It's still a work in progress, okay? So please bear with me. If you have any questions, leave them in the comments. I'll try and answer them. But a really interesting antenna, certainly the most frustrating antenna that I have ever built, but lots of fun, and really lots of fun how to learn and design a proper PCB, because I've only done a couple of simple ones before. Alright guys, hopefully that was of interest, and we'll catch you in the next one. Bye for now.